Hello and welcome. This video is about data representation. And previously you have learned, or we have learned, binary data, binary numbers, and converting binary numbers into binary numbers, and converting binary numbers back into binary numbers. Okay, so some of you asked, what's the point of learning that? In this one, we can start seeing the point. Okay, data representation. We need to use the computer to solve problems. So therefore, we need to tell the computer what problems we have. How does the computer understand us? It only understands binary numbers because it's using electricity, using on and off to represent data. So we must convert everything we want to tell the computer into binary. You can see the point of using binary numbers. Okay, and what problems do we have? Many real life problems. But what kind of data is involved? Now we know that we have the real world data can be numbers. Okay, let me find that one. Numbers. It can be text. Okay, text or symbols, and it can be a picture. You know a picture, okay, that's someone, and then that's a picture. Okay, and it can be sound. Sound in real life actually is sound waves and measured like that. Okay, you have frequency and you have amplitude. Okay, all of this needs to be converted into binary. Binary, that means 0 or 1. So what do we know now before this? We know how to convert numbers into binary. Yeah? Do you remember that? Okay, so place value, then you have 8, 4, 2, 1. Then you can go up to 16 and 32, 64, 128. Okay, now if I have number 1, 2, 3, then there's no 128 inside 1, 2, 3. You cannot divide 128 into 1, 2, 3. 0. 64, yes, you can divide into ones, then you have something left. How much left? 1, 2, 3, 64, and then that one borrowed is 6, 9, and then you borrow that one, 4 plus 1, 59. So you got 59 left. Therefore, 32 can divide into 59 once. 32, then is 7, 27. 27, okay, 1, 16. 27 take a 16, that's 1, 11. So you have a 1, 8. 1, 8, then you have 3 left. Then 3, you have no 4 because you only have a 3, therefore there. Now we learned how to turn this number into binary numbers, and then the computer will be able to understand them. Okay, so that's fine. Now we can turn numbers into binary numbers, let the computer work on it. Fine. What about text? Can we turn text into binary numbers? Okay. Now some of you said yes. You give each letter a number, like a code number, like a student ID code number. Yeah, each letter has a number, and that's what the American designers did many years ago. They designed something called ASCII. Yeah, in this ASCII table, each letter, each symbol has a corresponding code. For example, A could be 65 or 97. Look it up. Which one is A? The little a, which one is capital A? Okay, and look it up. Google ASCII tables. Okay, so with letters, symbols, we can turn them into numbers. And once you've got numbers, and you can turn them into binary numbers. Yeah, 0, 1. So that's all nice and easy. Good. So as long as you set up the rules, you know what each letter is for, what code is for each letter, then you can do them. Now, what do we do with the pictures? If we have a picture, how do I turn them into a computer file? We know we can do that. You can scan them. Okay, what happens during the scan process? Okay, when you are scanning the picture, you are cutting the picture into many squares. Okay, each square is called a pixel. Pixel. Okay, is a picture element. Each pixel is only one color. So you can have one color there, one color there. Okay, each pixel is one color. Now, this whole picture is made up of single colored dots. Yeah, you just make a lot of dots and use dots to make pictures. Okay. And then, because each pixel is only one color, if I can use a number to represent that color, then the pixel becomes a number. A number can be converted into zeros and ones. And you have many pixels, many different colors, then just have many different strings of zeros and ones, because if you can turn each number into a binary. Each number into a binary. Yeah? Okay, so to sum it up, a picture is divided into pixels. Each pixel is represented by one color. Okay, make it small enough so that it represents one color. Therefore, and you have a lot of pixels to make up one picture. And you can use numbers to represent the pixels. Okay, therefore, a picture turned into a number problem. As long as you can turn it into number, then you can turn to binary, the computer can work it out for you. Okay. Now you can imagine, same thing. If you have this sound wave, as long as you can turn it into a number, then or made into many numbers, as long as it's made up of numbers, then you can use computers to represent them inside the computer. That's what you say. Okay. How do you do that? You sample them. Sample. What is meant by sample? Sample. It means you are going to measure. You are going to measure the height at regular intervals. Yeah. So imagine if you measure them dense enough, then you can really reproduce the wave. Even though it's a lot of steps, not smooth, not as smooth as the original, but you can see the shape is there. And each of the step is a number because you measured it. Okay, the amplitude, you measured it. Okay. Now that is turning sound into numbers, and then you turn them into binaries. So all sorted. Okay. How often do you need to sample this? That would determine the quality of the sound. Okay, research what quality is better. Is a CD sound? What frequency? What sampling rate? That's the frequency is for CD quality. Okay, research that. So today we have covered how to convert different kind of real life data into binary data. So we represent real data inside the computer world using binary numbers. Okay, that's called data representation. Thank you.